Everybody, it's Eugene Liscio here, and welcome to Click 3D. This is the program where we talk about photogrammetry and how you can use nothing but a digital camera taking some pictures to make some really compelling 3D models. Today, we're going to be talking about an interesting topic that a lot of people don't consider, maybe, especially when they're new to photogrammetry. But before we get into that, I need to make an announcement here, and that is that I'll be hosting a photogrammetry week on January 26th, 27th, and 28th. And if you're interested, this is free. There's live webinars, and I'm going to be talking about photogrammetry in general, talking about the fundamentals of photogrammetry, talking about equipment, talking about software, and talking most importantly about different types of applications. So if you're new and if you're interested in photogrammetry, feel free to join in and you can register. Just go to my website, ai2-3d.com/register. In fact, when you pop up there, I'll bombard you with like a page where you'll see all the registration and everything else. So you should be able to find it relatively easily. Okay, so today's topic is one which I am going to kick off here, and I'm going to share this to this screen, and that's going to be on lens distortion. And so no matter what your camera and your lens combination is, if you have a separate body and lens, okay, they are very unique. They're always unique and they have very special characteristics. And so that's what we're going to be discussing today. So first thing, whenever you look through a piece of glass, you're looking through a distorted image, okay, no matter what. And I always say that looking through a lens is like looking through a glass of water or like a goldfish bowl. And that is, light gets bent in ways that are not just like in a vacuum, and they don't come straight to your eyes. They get bent around the edges. There's different indexes of refraction, and so things bend and change. So keep that in mind, because if you're just taking pictures for your family or your friends, no big deal. But if you're going to be taking pictures for measurement purposes, you need to understand exactly what's happening to the light and how it's being bent. And so that's why many software packages will calculate the distortion parameters of your camera and lens these days. So very, very important. Now, lenses are made with different materials, and silica, quartzite, borax, things like that. And so you basically start with a mixture of powders, you put them all together, and then what you do is you heat them to a very high temperature and you make glass. And depending on the types of materials that you have in there, you can change the color of the glass. So when considering a camera and the lens on a camera like a Nikon camera here that I've got, we don't want any color in here. We want it to be as clear as possible, and so we don't want it to be blue or yellow or anything else. So getting the right mixture of materials and elements is really, really important, and there's a whole science behind that as well. Now, once the glass is melted, or they often will pour them in sheets, they'll break them up again and actually remelt them, okay, and they'll take a little globule of glass and actually press it like into a mold, so that at least they get the general shape of what it is that they need. And then what they do is they anneal it, and anneal it is relieving the stresses in the glass. And if you were to just take hot glass and pour it out on a table or something like that and just let it harden, there's a lot of internal stresses inside the glass, and sometimes as it cools, it just shatters on its own. So in order to avoid that, you anneal the glass, and you get up to about 500 C, and then you gradually allow it to cool. Now, the lenses, of course, have to be ground. And in the old days, when people were first making glass, they would take two pieces of glass and then put some kind of a I forgot what the word is now, but it's some kind of a powder or a slurry. That's what I'm thinking of, in between the two, and they'll rub the two pieces of glass together, and eventually they'll start to create a concave or convex shape between the two. Well, of course, today we have machinery that will do that for you, and so you grind and then polish the lens to the shape that you want. And the polishing is obviously to make it very, very, very clear, and also to make it very accurate, right? We don't want a lens with a lot of little waves and that sort of thing. So that's very, very important. Now, when we talk about camera characteristics and understanding a camera lens just like this, okay, let's talk about some of the things that we need to know about it, especially if we're looking to take measurements. So, one thing is the focal length. Now, most cameras, on the camera or on the lens, right, you'll look on the side here and you'll see that it says something, right? So this one says 70 to 210, right? If you grab another lens and you look at the reported uh, focal length, right? There's a number of numbers that there's a number of numbers that are written here, so you'll see them there as well. So these are not the actual focal length, okay? These are estimates. They're pretty close, but they are not true values. So when it says it's 18 millimeters, it might be 18 millimeters, but it might be 17.8, it might be 18.2, it could be more or less depending on the type of camera and how it comes together. So remember, focal length is important because it defines your field of view, right? How wide you're looking at something and how far the lens is from the imaging plane. So focal length is something that we're going to try and determine. There's also different types of distortions like barrel distortion and pincushion distortion. So barrel distortion is often associated with wide angle lenses. So if you have like a 14 millimeter lens, you can see a lot, but you're bending the light quite a bit. So you end up seeing that the edges of the image or the picture that you're taking are going to be bent. Security cameras are notorious for this. So if you look at the security, a security camera with a wide field of view, you'll notice that the edges get really, really, really bent. And so that may look something like this. This is a GoPro, and just looking at the wide field of view that it has. But of course, something that we know should be straight. It makes straight objects look curved. And the effect of distortion gets greater when you're on the edges of the image. So near the center, it's not too bad. You'll notice that in between these two mailboxes here, it's fairly straight, but then on the edges, you'll see it gets really, really bent. Okay, so keep that in mind. The effect is exaggerated as we get farther away from the center. Now, there is an opposite effect to this, which is called pincushion distortion. And pincushion distortion happens when you have a long focal length. So a telephoto lens or something like that, when you look through it, you'll notice that they start to bend the lines bend inward. They're bending in like a pincushion, or they're bending in the other way. So not as common to see, but you will see it on a telephoto lens for sure. And that will look something like this. So this is an image where you can see just a little bit of bending on the edges, not a lot, not heavily exaggerated, but enough that, if you were taking measurements from something like this, well, it moves, makes straight lines bent. So it means that pixels are not where they actually should be. Okay, so keep that in mind. Another effect that you can get on a camera is a decentered lens. And so if you have a camera body and you have it attached to the lens, well, you can get a problem when this is not centered, like right in front. So let me click on this. What happens if during the manufacturing, there's a slight shift of the lens inside? Fortunately, today, with machining tolerances and everything else, they do a pretty good job of holding these things pretty steady, but they're mass produced as well. So way back when, in the old days, they would make metric cameras, and those cameras were manufactured to a very, very high tolerance, high degree of accuracy. But today, because these are, there's plastics and metals and combined stuff that's being put together here, they can shift. And so they may not be perfectly centered. So the lens relative to the camera body and relative to the sensor that's inside makes a difference. So decentering can be an issue, and it's something that we can solve for by doing a camera calibration. There's also a different alignment issue, which is like tangential distortion. So if I have a lens that's on the camera body, let's say I bump it or I hit it or something like that, and all of a sudden it is kind of moved up a bit or moved down a bit. Well, if you change the position of the lens relative to the sensor, well, then you're going to be shifting the image on the sensor. And so that's going to cause a problem when you want to take measurements. So all these alignment issues, any small adjustment here, that's going to have some problems in terms of getting a true image, okay, or getting the best quality image that you can so that you can take measurements. Now, there are other things as well, like nonlinear defects. And that is because your camera lens is not perfect. So it is highly, the lenses are made, they're ground to a very, very high degree. But any little inconsistencies and over time or whatever, things can change, things can shift. So the effect may not be linear. So if you were to look at an image, like the barrel distortion image that I had before, things were relatively even. Okay, but things can be shifted, and even on the lens, any small defects or whatever can cause light to bend differently or unevenly. So that's a really important point. And we can exemplify this in an image here. So let me bring this one up. So on the left, I have an image that I've taken of a ruler, and I've got some targets on the ground, and there's like a tire track there that I'm photographing. You'll notice that the ruler is a little bit bent, and let me bring that and make that a little bit larger. You might be able to see that better. Okay, so there's a little bit of bending in this ruler. But when we calibrate a camera, we can actually fix that a little bit. And when we fix that, we correct the image. We correct the image for distortion. We correct the image for all those little things that the decentering and that sort of thing. And in fact, if you look at the image on the right, you'll notice that there's a little bit of a black border, and that black border is not even. Okay, so it's larger on one side than the other, larger on the right side than the left, and larger on the bottom than the top. You'll also notice that it's tucked in. Okay, there's a little bit of curvature there. So it's bringing in the image so that the curvature, any curvature that it introduces, okay, it's going to remove. And so that's an optimized, or in Photomodeler, for example, they call that an idealized image. So, like I said, video cameras, like security cameras, they're notorious for having a lot of distortion. So much so that the image looks really weird, looks something like this. So this board that's being held here is nice and square now, and that's what we want. We want to make sure that lines are straight and that sort of thing. But you'll see that there had to be a lot of correction to this particular image in order to get it that way. So keep in mind that there are different levels of distortion for different things, and that the way that we correct for them is through a camera calibration. Now, I will say this. Many things, or many programs today, will automatically account for camera distortion. Okay, so when you're taking a lot of different photographs and you can pick up a lot of different points at the same time, it can determine where points are in 3D space, and it can figure out that they are being bent by the lens or by the camera combination, and it can correct for those distortions to give you a true 3D model. So this is not something that you typically need to do anymore when you're using programs like Metashape or Reality Capture or 3ds Zephyr or even Photomodeler. It's inherent. However, it can help in many cases, and it's a great way to look at your camera and then determine how much distortion there actually is with a different lens. Now, if you have a camera and you change the lens on it, so you've got a DSLR, you remove a lens and you put another lens on there, you're going to be subject to different distortions. So when you do a camera calibration, it's very specific to a lens and camera body combination, and also a set focal length. Okay, so keep that in mind. If you're going to be using a lens that has a range of focal lengths or zooms, okay, you pick one and you calibrate it there, or you can do several. But the problem is it's very hard to determine when you're in between. So I either do, like on a lens that goes 18 to 30, or 18 or 18 to 70 or something like that. You choose the low end. I choose 18, wider field of view, and I usually correct for that. And you can do a camera calibration after too. But it really helps too with single images. So if you take a single photograph and you know how much distortion is in an image, you can correct for that single image. And so that can be helpful sometimes. So what we're going to do right now is we are going to do a camera calibration. And there's different ways to do camera calibration. There's different programs. They treat them differently. There are, for example, target sheets that you can use like this. So this is a set on the left, and on the right, these are coded. These are targets from Photomodeler. In the middle is just a checkered pattern. Some programs use a checkered pattern. Some programs use a noise pattern. It just looks like a bunch of noise on the screen, and you take photographs. So today what I'm going to do is I'm going to take photos using Photomodeler. And the reason that I'm going to do that is because it's very structured. Okay, it's a very structured way of doing that. And so what I'm going to do is I'm going to use their old style target sheet, which was this big square one, has a lot of dots and some of these coded targets. And I'm going to take my camera and I'm going to photograph from each side. But while I do that, I'm also going to rotate the camera. And then what I'm going to do is I'm going to come back and I'm going to process the images in Photomodeler, and I'll show you what it does, or how that procedure works. So let's take a break here, and then we'll be right back to process this in Photomodeler. Okay, so I'm here and I've got a target sheet here from Photomodeler, and I like their system. It's pretty easy and it allows you to print these out in larger sizes. So this is their older target sheet, but I had it kicking around and it was pretty easy. I showed you one of the newer ones that had a bunch of these coded targets that you can print out on an 8.5 by 11 sheet, and you print out like, you know, a dozen sheets or so, and then you just kind of spread them around into a wider format, and you take pictures. But I'm going to walk you through the general process here. Now, you could print this out smaller, and so it doesn't have to be this size. If you're taking photos of smaller objects, you know, it's absolutely fine, perfectly acceptable. You know, if you're using a macro lens and doing something smaller and you want to figure out what the distortion is on your particular camera and lens combination, so be it, you can do that. So I'm just going to move this out of the way and walk you through the basic process here. Now, normally you would use a tripod to do this, okay? So you need to get a really, really sturdy, nice tripod, okay? You tape the paper down. You don't want it floating around or moving around, and you would do it this way. But it's just easier to show the process with me holding a camera in my hand, okay? So you're gonna be using a tripod if you wanna use this, and but I'll show it to you by hand here. So normally what I'm gonna do is I'm gonna take the camera and you're gonna go around, you're gonna repeat this process for each side. And you can do this different ways. One way is, I like to do it this way, and that is that you're gonna basically make sure your lens, especially if it's a zoom lens, okay, you make sure that it's set on the lowest setting. It's hard to one side, so this is an 18mm lens, and I'm gonna go like this, and I am gonna basically just take pictures, and I need to set this properly. And I've already done this, so I probably won't just actually take the pictures, but I'll show you what I mean. You want to get a good angle, about a 45-degree angle. And in this case, I need to get as many of these coded targets in as possible. So just those 4. And so long as I got those 4 in there, I can actually cut off these dots that are on the outside. Okay, so those 4 are the most important. I always have to have those in every single image. So I'm going to take a photo like this with the camera in a normal position. Then I'm also going to rotate it positive 90 degrees, and I'm going to get as close as I can to get those 4 targets. I'm going to take a picture, and I'm going to rotate it negative 90 degrees. And I'm going to take a picture like this. And you want to have a pretty decent angle. Now, one little trick that I do is I pick the bottom of the page, and no matter which way I'm looking at it, I always try to fill the bottom of the view, whichever way I'm holding it, with as many dots as I can. And that means the top might be empty, okay? You may not have anything there. But if I hold it this way and I've got targets on this side, and then I hold it this way and I've got targets on this side, I'm filling up and maximizing the lens so I get the maximum amount of coverage as possible. So I'm gonna repeat that process all the way around. So like this, take a picture like that, one like this, and then one like that. Okay, then I'm gonna move to this side. Okay, and I'm gonna hold it at about 45 degrees or so. I'm gonna click, click, and then click this way. Okay, then I'm gonna come over this way, and I'm gonna do the same thing. Okay, like that, and like that, Yes, I just turned it on. Like I said, I already did this, and then I'm going to come back this way. 1, 2, okay, and 3. Now, if you are going to hold it by hand, have a lot of light because it's going to help you, and you want to get the a very quick shutter speed time because you don't want to be moving this around. If you blur these images, they will definitely not process all that well. But for now, it's fine if we just run this through Photomodeler, and then I'll show you how it happens. And it's super, super simple. So let's go back to the computer and let's see what happens. Okay, so we are now at the Photomodeler interface here. And what I'm going to do is load up some images. So let's do that. We're going to start a calibration project. And I'm going to go click here to add some images, and I've got these on or in a folder here, so I'll just do that, load these ones up. So I just took these pretty quick, and I find that whenever I do a camera calibration, I never accept the first one, even if it seems okay. I try it several times and try to see what I can improve, so please keep that in mind. This is going to be really quick here. But Photomodeler will have a look at the images, and because it's a camera calibration project, it will try and figure out what kind of sheet that you're using. So it's automatically said that I'm using the single calibration sheet and not the multi-sheet calibration. So what I'm going to do is just going to go ahead and hit run. And it's going to do all the work for me. I really don't have to do all that much. So the first part is obviously detecting the dots. And so it found 4 coded targets, and then in some images, 140, 127, 130, 140 of the regular points. And once it's found all the images, it's going to go ahead and run through and try to figure out what it can from this. So let's see what it did in this particular one. So if I want to look or I want to show the report, I'm going to do that here. Okay, and here's the status report. And so it says no problems or suggestions. So that means that it worked out well. Now, that doesn't always happen like this, okay? There's often a lot of issues, but as you go down, you'll see that the value of the focal length is 18.61. So even though it says 18, it's not, okay? It says 18.61 over here. And it gives you things, a whole bunch of different values here. I don't want to get too much into it, but a lot of these have to do with the type of lens distortion and how the image is being projected on the center, sort of its position and that sort of thing. So the really value that I want to get to, though, let me just go back up here and I'll show you. Let me minimize this. And if I go to quality, and what I want to do is go to the residuals. So overall, the RMS is 0.356 pixels, and I had a maximum of 1.377. So that's not too bad considering the kind of camera that I have. We try to get the maximum if we can. I've got 1.377, but I know this camera is a little bit difficult to get under 1 pixel, but that's really what we would try and get. We would try and get this value of 1.3, the maximum under 1 pixel, even though my RMS value is 0.356. And that's telling you that overall, everything is within a pixel in terms of accuracy. So it's kind of figured out what Photomodeler is doing here. And I can save this. So I can save this to my library of cameras and that sort of thing. But that is basically what you're doing here. So if I want to, what I'll do is I'll accept this. I'm going to close this and I'll say, yeah, sure, go ahead and add this to my library, no big deal. And I'll have a look at the image here. You'll see that it has a whole bunch of points that it's marked on the dots and also on the coded target. It knows what that is too. Now, if I want to, I can do what's called an idealize. So that's where it starts to remove the distortion. Because right now I'm just looking at a, at the regular image. But what I'm going to do is I'm going to run the idealize process. And so that's going to actually correct the image so that what the computer can sort of figure out is going to visually be presented to me with all the distortions and that sort of thing removed. And that's really useful sometimes. Also, if you're working in a program like 3D Studio Max, or you're working in other software where you're going to be taking the camera positions, and you want to project sort of the background image. This is sort of an advanced topic, not really for calibration, but you do need to figure out what the idealized images look like and then use those in another 3D program. So in a second here, it's going to tell me if I want to reprocess. I'm not going to reprocess because it's going to get the point across. But if you look here, you'll see it's hard to see because there's a black edge, okay? But if I zoom in and I tuck this over, okay, you'll see that there's a black space here. So that's part of the correction that it's made. If I had a white background here, it would have been a little bit easier to see. But hopefully you can see, let me move that over again, that there is definitely just empty space here. And that's where it's tucked in the image to correct for the lens distortion. Let me see if I've got a white image here or something that I've cut off. Yeah, this one, maybe it would be better. There we go. That looks a little bit better to me. So if I look at the bottom here, okay, this actually went off the page. You can see how it's tucked in the bottom of this particular image. And so this gives you a sense of the type of distortion that you have on your camera. So that's all I'm going to do for today in terms of talking about camera calibration. Almost every photogrammetry program will have this available, you know, as an option. And some programs will, you know, have checkered patterns. Some have like a noise pattern. You have a lot of different options. This is a good example of what you can do with calibration in Photomodeler. Okay, so that's what it looks like in Photomodeler, and that's camera calibration. And so I hope you learned something about your camera. If you want to give it a shot, sometimes there's free programs that you can use that will allow you to do camera calibration, and it's a really great way to see what kind of distortion you have in your camera. So on that note, I want to say thanks a lot, everyone. Look for us next time on Click 3D. Thanks a lot. Bye-bye.